Welcome to The Explainer. What if I told you that the entire race to build the biggest, baddest AI is completely wrong? Today, we're diving into a wild new idea coming out of Tokyo that says the future of AI isn't about manufacturing at all. It's about evolution. So right now, when you look at AI development, there are basically two camps. On one hand, you've got the monolith approach. Think of it like building the Death Star. One single gigantic, all-powerful model. But then there's this other idea bubbling up, the ecosystem approach. This is less about building a machine and more about, well, growing a garden. And that first approach, the monolith, well, it's turned into this insane arms race. We're talking billions upon billions of dollars being poured into building these digital titans. It's a game that only a few tech giants can even afford to be in. And the cost, both financially and for the environment, is just staggering. But what if that's not the only way? A really interesting startup out of Tokyo, Sakana AI, is proposing something totally different. Their whole philosophy isn't about manufacturing. It's about biology. They're saying, hey, let's stop trying to forge the one perfect sword, and instead, let's learn how to cultivate an entire forest. Okay, so this brings us to their core idea. It's a technology they call M2N2. Now, that stands for Model Emerging of Natural Niches. And yeah, as you can probably guess from the name, it's all about copying Mother Nature. So how does it work? Instead of spending a fortune to build an AI from scratch, M2N2 takes what's already out there, all these amazing open source models, and it breeds them. Seriously, it takes two parent AIs, merges them together, and creates a new offspring AI that gets the best traits from both without any of that ridiculously expensive retraining. Okay, so you're probably thinking, breeding AIs? That sounds like a cool metaphor. But it's not. This is the amazing part. The M2N2 algorithm is quite literally built on three core ideas taken straight from Charles Darwin. And here they are: survival competition, smart mating, and genetic recombination. You put these three things together, and suddenly you have a whole population of AIs that can evolve and specialize all on their own. It's evolution, but for code. All right, let's break that down. First, competition. Think of it like this. If a bunch of AIs can all solve the same easy problem, they have to split a tiny reward. But if one model can solve a really tough problem that no one else can touch, it gets the whole jackpot. This system basically forces the AIs to get creative, to specialize, and to find their own little niche where they can be the best. Okay, next up, smart mating. This is where M2N2 plays matchmaker, and it's smart about it. It knows that just taking the two best models and smashing them together is a terrible idea. That's like putting two amazing goalies on a soccer team. You're not going to score any points. Instead, it looks for models with complementary skills. It finds an AI that's great at offense and pairs it with one that's a rock star at defense. And this brings us to the final and maybe coolest piece of the puzzle, genetic recombination. When it merges these parent models, it's not just stitching them together at the seams. It uses something called dynamic split points to dive deep into their code, kind of like shuffling a deck of DNA. It can mix and match parts at a really fundamental level, creating totally new combinations, things a human engineer might never even dream up. Okay, the theory is beautiful, right? It's elegant, but does it actually work? Well, this is where it gets really, really interesting. Sakana AI put it to the test, and the results? They were pretty mind-blowing. Get this. For their first experiment, they started with nothing. Just a bunch of completely random neural networks. I mean, pure digital noise. And then they just let the M2N2 process run. And from that chaos, it evolved a working, high-accuracy image model. This had never been done before. It proved M2N2 isn't just a tool for combining AIs. You can actually create AIs with it. All right, next test. They took a MathWiz AI and a web-serving pro AI. They merged them, and the new child AI, it could do both perfectly. Now, this is a huge deal because normally, when you teach an AI a new trick, it gets something called catastrophic forgetting. It's like it forgets its old skills. M2 completely sidestepped that problem. But the real jaw-dropper, the one that made everyone sit up and take notice, came from an experiment with image generation. They took a model that was really good with Japanese text prompts and merged it with a few English models. The goal was simple, right? Just make the pictures look a little nicer while keeping the Japanese skills intact. But something absolutely wild happened. They were only optimizing for Japanese, but the new model's ability to understand English prompts shot through the roof. It became better at English than any of its English-speaking parents. You can see it right here on this chart. That higher bar for the merged model means it got way better. This wasn't programmed in. Nobody told it to do this. It was a completely emergent ability. That's real, honest-to-goodness evolution happening in silicon. So let's zoom out. What does all of this mean for the future of AI? Because this is way more than just a clever new piece of code. We could be looking at a total shift in how we even think about creating AI, from building it to growing it. This is a genuine paradigm shift. We're talking about moving away from the AI factory, expensive, exclusive, slow, in toward an AI garden. It democratizes things, right? Anyone can start mixing and matching open source models. It's way more efficient, it allows for constant updates and evolution, and maybe most exciting of all, it creates the potential for these amazing, unexpected breakthroughs. Now, obviously, it's not all sunshine and roses. There are some big hurdles to overcome. How do you make sure two different models can even talk to each other, let alone merge? And as you start creating these complex, evolving AI systems, well, the security and legal questions get really, really tricky. That's for sure. But it leaves us with this incredible, provocative question. For so long, the term has been building AI. But maybe that's been the wrong verb all along. Maybe the future of artificial intelligence won't be manufactured in a factory, but grown in a garden,